Right, well, welcome to the thrilling part 2 of Binary is My Friend. And today we're going to cover where do subnet mask values come from. I know you just can't wait to find out, so let's get started and work this out. As before, what we're going to do is we're going to go through and we're going to use a simple pen and paper. And at the top of the page, we're just going to write in the values for our octet. So we're going to put in 128, 64, 32, 16, 8, 4, 2, and 1. So we've got one octet there, and there's only so many values we can actually have for our subnet masks. Now, again, historically, we are bound by the fact that routers were pretty simple devices in the early days. And essentially, they could only deal with subnet masks that had contiguous 1 bits, meaning there was no gaps between any of these. And they also started with the high order bits, so they'd start up this end at 128. And essentially where the first 0 bit came would be where the network portion would end and the host portion would begin. Now, you're probably used to seeing values like 255, 255, 2550, and you think, oh, that's what a subnet mask is. But where does the value come from? Well, let's just find out. Again, binary really is your friend. And you only really need to do this the once to prove it to yourself that this is where they came from. And you never need to do it again. But if we do this now, we'll see that the first valid subnet mask value that we have is from that first 1 bit. So that equates to 128. So there's our first valid subnet mask value. In fact, we're going to be really pernickety about it. You can have 0 as a value as well. But we'll move on. So what's our next valid subnet mask? Well, as we have to have contiguous high order bits, it's now 1, 1. And then the rest are zeros. So 128 plus 64 makes 192. So there's our second value. Third value, I think you can see where this is going now, can't you? Is 1, 1, 1, and then all of the zeros. So 128 plus 64 is 192, plus 32 is 224. These are really good, useful values for you to be able to add up. They will come in handy. So if you can do this in your head, so much the better. Next valid subnet mask value, again remembering contiguous high order bits. 128 plus 64 is 192, plus 32 is 224, plus 16 is 240. Put in the remaining zeros, and there we are. So you can see there's not too many valid values that we can actually put in, but let's just carry on the process. So we've got 240 plus the 8 is 248. And then keep going, just a few left to do. 248 plus 4 makes 252. And then almost there, 252 plus 2 makes 254, and then finally we end up with the one that you're most familiar with because it's the one that we use in our default values. It equates to all the ones, and in certain instances means we are using a broadcast, so 255. So there you go. You've now basically worked out where all of these values come from. They're now no longer mythical, strange decimal values that you think, where on earth did they come from? You can clearly see by looking at the binary exactly where they come from. So there you go. I hope that sorts it out for you and makes it nice and simple.